EET 114, Chapter 18, Section 7 is delta to Y and Y to delta conversions. Problem 37, using the delta Y or Y delta conversion, determine the current I for this network. So the current I is the source current. You know what the voltage is, this voltage source, and then you have a 2 ohm resistor, then you have a delta configuration here, and you have what they would call a pi it's a pi configuration, which is also, this is also a delta configuration because they just drew it a little bit differently. They could have drawn this 3 ohm inductor at an angle like this, and this 3 ohm inductor at an angle like that. So it's basically a delta here and a delta here. Now, in order to convert to a Y given a delta, you need to use these equations here, right? You're given this delta A, B, and C, and you want to convert to Z1, Z2, Z3, so you use this set of equations. They chose to simplify the top portion. And there's another reason they chose it, because all three of these impedances are equivalent, okay? So they took a shortcut. If they're all equivalent, then you just take the delta impedance and divide it by 3 and you'll get the Y impedance. Okay, if you see that if all three of these Z's were equivalent, you would get Z squared on the top divided by 3Z on the bottom, which would be Z divided by 3. So they took that 12 minus J9, which is on each leg, divided it by 3, and that you get this 4 ohm minus J 3 ohm. So then when you do that conversion, you get this Y that looks like this, okay? And it's a resistor, 4 ohm minus J3 means a capacitor of 3 ohms. So from there, it's kind of easy to figure it out because now you have these guys are in series and then they split off. This is in parallel with this, and then these happen to be exactly equivalent. Also, it's just to make the problem easier, they did this. So you get to get your total impedance, you start up here. You have the 2 ohm plus the 4 ohm minus J3, and then you have these two guys in parallel, this 4 ohm minus J3 plus J3, which is in parallel with, again, with the 4 ohm minus J3 plus J3. So the minus and plus J3s cancel out to be 0, so it's really a 4 ohm in parallel with a 4 ohm, which is 4 times 4, 16 divided by 4 plus 4, which is 8. 16 divided by 8 is 2. And then 2 plus 4 is 6 here. So, okay, I fixed a mistake in the book. There should have been a negative sign. So it's 6 minus J3 plus 2, which is 8 minus J3, which is 8.544 ohms, angle negative 20.56. So to find the source current, it's just E divided by the total impedance. You're given that E up here, so that's 60 volt angle is 0 divided by 8.5 angle negative 20.56 equals 7.02 amps, angle of 20.56.